In today's question, on a smooth horizontal platform, a mass of 2 kg is dragged along a horizontal force with a horizontal force of 10 Newton. On the platform, there are so many holes spreaded on its surface, below which is an air blower which exerts a force on the block in the upward direction depending on its height above the platform, as F is equal to 22 minus h Newton, where h is the height of the block above the platform. Let at t is equal to 0, block starts from the rest from the origin of the coordinate system. Find the equation of the trajectory of the block during this motion. Consider x-axis along the motion of the particle and y-axis in the vertical up direction. So in case it is given that we are going to find out the equation of the trajectory. So basically the equation of trajectory, it means that we are going to find out what will be the x direction motion and what will be in the y direction motion, and accordingly we are going to solve it, and thus we are going to get the equation of the trajectory. So first we find out net force in the horizontal direction. Net force in the horizontal direction, let us call that Fx, and this will be equal to m into Ax, and Ax is already given as 5 meter per second square. So and Fx is also given as 10 Newton. So we substitute the value as Fx is equal to 10, and mass is also given. Sorry, Ax is not given. Fx is given as 10 Newton and mass is given as 2 kg. So we write 2 into Ax. Okay, so from Ax will be equal to 5. So we can write this as Ax can be written as derivative of velocity in x direction with respect to time will be equal to 5, and this can be further written as with respect to dv by dx and dx by dt is equal to 5. Now dx by dt is nothing but velocity in x direction. So we can write this dvx, derivative of vx is equal to 5 into dt. Now integrating, we can write this as vx square divided by 2 is equal to 5x, or from here you can say that velocity in x direction is equal to 10x. So let us call this equation number 1. Similarly, you can say similarly in y direction, Fy will be equal to 22 minus h minus mg, and Fy will be nothing but mass into acceleration in y direction, and we can write this as and okay 22 minus h minus mg, and in in y direction, let us suppose that height is equal to y. So we put the value MAY is equal to 20, 2 minus y, and this will be g we are going to take as 10, so this will be 20. And similarly, as we did in the first part, we can convert this into 2 Vy dVy by dy is equal to we can just open it. This will be coming as 40 minus 20y minus 20, so this will be 20 minus 20y, or Vy derivative of Vy is equal to 10, and this cancels out, so this will be coming as 10 minus 10y dy, and once again integrating. By integration, we are going to get this as equation will be coming as Vy squared is equal to 10 2y minus y square, and let us call this equation number 2. Okay, so dividing equation 2 by equation 1, we get Vy upon Vx will be equal to 2y minus y square divided by x, and its square root, and Vy we can write this as dy by dt, and Vx we can write as dx by dt is equal to 2y y square divided by x and its square root. So dt cancels out. So further we can write this as dv by dx is equal to 2y minus y square square root divided by square root of x. We separate the variables. Okay, so we can write as dy divided by 2y minus y square square root is equal to dx divided by square root of x. Now we are going to integrate both sides. So this will be coming as sine inverse y minus 1 is equal to, sorry, not equal to, but minus pi by 2 is equal to 2 square root of x, or we can say y is equal to 1 minus cos 2 square root of x, and this can be further solved as y minus 1 is equal to minus cos 2 square root of x, and this can be written as pi minus sine of 2 square root of x, or you can say that 2 square root of x is equal to sine inverse y minus 1 minus pi. So this is the equation of the trajectory. Thank you.